So in this video, we're going to go over just the three methods again on how to solve systems of equations. We're going to use one method for each of these problems. On the first one, we're going to do substitution. Remember, for substitution, you want to get it to either x equals or y equals. And on this problem, we're going to make it x equals y minus 2 by moving this negative y to the other side and making it a positive y. Now that we know what x is equal to, we can use that and substitute it into the second equation. And if we substitute that in for x, we end up with 7 parentheses y minus 2. That's where we got our x's, plus 2y equals negative 5. If we solve this out, we get 7y, and 7 times negative 2 is minus 14. Everything else comes down. We combine our like terms. We end up with 9y minus 14 equals negative 5. Move this negative 14 to the other side. It becomes a positive, so we have 9y equals 9, and we divide both sides by 9 and get y equals 1. Now that we know our y value, we can easily plug that back in right here, and we end up with x equals 1 minus 2, which means x is equal to negative 1. Substitution. The next method we're going to do is elimination. And like I said, even though this doesn't look like a problem I would use elimination on, because our variables are lined up, we got both of our x's, we got both of our y's, we can think of something that we can multiply one or both of these equations to get this common coefficient. So we're going to multiply this whole top equation by 4 and this whole bottom equation by 5. The reason we're doing that is because we can end up with the common coefficient of 20. 4 times 8 is 32, 4 times 5 is 20, and the 4 times negative 13 is negative 52. We're going to do the same thing with the bottom equation, the 5 times all of our coefficients and our constants, and we end up with 15x plus 20y equals 50. Now that these both have common coefficients, we can subtract these equations to eliminate this variable right here. If we subtract, we end up with 17x equals negative 102. Remember, right here we have negative 52 minus 50, so be careful. We divide both sides by 17 to get the x by itself, and we end up with x equals negative 6. And now that we know what our x is equal to, we can plug that back into one of the original equations to figure out what our y value is. So if we plug it back into this one, we end up with 3 times negative 6 plus 4y equals 10. That gives you negative 18 plus 4y equals 10. Move this to the other side, it becomes positive. You have 4y equals 28. And that means divide both sides by 4 and you end up with y equals 7. So our solution is negative 6, 7. Last but not least, we have graphing. We're going to use graphing for this example, but remember, in order to graph, we need both of our equations to be y equals. So to solve this top equation, we're going to move this x to the other side, and once we do, it becomes a negative 4. We divide everything by negative 3, and we end up with y equals 4/3 x minus 6. For this second equation, all we need to do to get the y by itself on this one is to move this 2x to the other side. It becomes a negative. And yes, there's still a 1 in front of this y. We don't have to divide everything by 1. It's not going to change anything. We graph both of these equations. I'm not going to go over that to save time, but we can graph both of those equations by hand or in Desmos, and we end up with a solution of 3, negative 2.